I'm going to go over all the properties of the logs on this section and start by the product property. Notice that as you multiply x and y, you would break that out as the sum of the logs. Dividing, you're going to subtract the logs, and this is called the power property, where you have an exponent of your x, whatever your x may be, comes out to the beginning of the log. And the last property is the change of base formula. Change of base formula basically says if you have log base b of x, it's equal to the log of some base of x over the log of some base of b. Now, normally you would break it down into the common log or the natural log. These would be equivalent ratios, so you could do either one. I want to go through a few examples of this. So one type of question that you may have is where you're going to evaluate this, which just basically means that you want to condense the expression. And when you condense the expression by applying the properties, you would first write it so it looks like no multiplier out front. So we're going to use the power property. And now that you see that those bases are the same, you can apply the product rule that says that you can combine those into 27 squared times 1/3 to the 4th. And then it's a matter of simplifying this. So that's going to equal log base 3 of, you could just expand that, 27 times 1/3 times 1/3. And now you can see that 9 goes into 27 3 times, and the same as the second one, log base 3 of 9, and that is equal to 2. Another type of problem that you can have is something called expanding, and this expanding looks like, with radicals, it looks kind of strange, so you're going to want to get rid of that radical first to see what you're looking at, and so that's going to be t to the 2/3 power. You got t's and r's, so you can't combine any of that. Next, we want to separate that out, so it's going to be log base 3 of 5r5. This is the quotient rule, minus log base 3 of t to the 2/3. And then you're going to want to separate all that out. I'm going to do a couple steps at the same time. This is product and power rule. So it's going to be log base 3 of 5 plus log base 3 of r, and there's a 5 out front with that power property, minus 2/3 log base 3 of t. Condensing, when we condense this, that means we're going to make it into 1. So let's see, the 11 would mean that it's up here as an exponent. Same thing with the 5, but we have to make sure that this whole thing is to the 5th power, and therefore it's going to be the log base 9 of x minus 3 to the 11th, all divided by 2x to the 5th power. Looking at a few other examples, when you evaluate this, all it's looking for is to expand it by either by the change of base law, and that's just going to be something that looks like this, and you'd use your calculator to figure that out. You could also do the common log or the natural log, which would be 32. again, those ratios would be equivalent. This is a problem that forces you to use the properties of logs by following this rule. So if I'm going to write this down, I could write that as, let's see, 2 squared times 5. And in this case, you would have 2 log of 2 plus log of 5, and log of 2 is a, so it's 2a plus log 5. Similarly, breaking this down, log of 2 times 3 squared, that is going to equal log base 2 plus 2 log of 3. Now I substitute in, and I'm going to have a plus 2b. Similarly, 2 squared times 3 log substituting in 2a plus b. Last one, decimal. You want to get rid of that decimal first by writing it as 9/2. Then it's the log of 9 minus the log of 2, which is 2 log 3 minus log 2. By substituting in, you're going to have 2b minus a. So just looking at the product, quotient, power, and change of base rule, and doing a few problems on logs.